This will be our lesson on permutations and combinations, which is our first section of statistics. The first concept we need to know about and understand are factorials. Factorials are going to be written a number, comma, exclamation mark. To do that math, like number 1, 2, what we're going to do is we're going to take the number, we're going to count down to 1, and we're going to multiply all the terms together. So that's read n factorial. So number 1, 3 factorial, what we're going to end up going to do is we're going to multiply 3 times 1. I'm sorry, back up, make that 3 times 2 times 1. I'm going to be going back and forth between a few different screens so we can get all our work done. So 3 factorial is going to be the same as 3 times 2 times 1, which is going to give us our answer of 6. So when you have a factorial, you're going to start with that number, you're going to count down to 1 and multiply all your terms together. So for number 2, 7 factorial, we're going to end up multiplying 7 times 6 times 5 times 4 times 3 times 2 times 1. Reality, we're not going to do that in our head, but if we had to, we would try to multiply pieces together that would give us good values and go from there. But we'll go to our calculator. 7 times 6 times 5 times 4 times 3 times 2 times 1, 7 factorial, and get an answer of 5,040. So go into our paper, 7 times 6, 5, 4, 3, 2, 1. Multiply those all together, and we're going to get 5,040. All right, number 3 is 6 factorial over 4 factorial. Doing that, 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. So we would need to, or one way to do this would be to multiply everything across the top, multiply everything across the bottom, and then clean up the math. All right, so what's going to happen is if I do that, 6 times 5 times 4 times 3 times 2 times 1, 720 over 6 times 4, which is 24, divided by 24, we're going to get 30 as an answer. All right, but being smarter about this, because I'm multiplying all these terms, 4 on top and bottom cancel, 3 on the top and bottom, 2's and 1's cancel, give me 6 times 5, which gives me 30. At any point we're doing these lessons, you can pause the video and do your math yourself so you don't have to watch me do all of it, and you can try them all on your own. I'll try to pause a little bit, but use the pause option to do that. All right, so try number 4 for me. 9 factorial over 10 factorial. So same idea, all the way from 9 down is going to cancel, giving you the answer of 1 over 10. So when you recognize that from 9 down is going to cancel, we're not going to write that out because we know 9, 8, 7, 6, 5, 4, 3, 2, 1 all multiplied is 9 factorial. On the bottom, it's 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1, which is 10 times 9 factorial. Understanding that 9 factorial counts down, I can just cancel and get 1 over 10. So you don't have to write them all out. Once you realize a certain number down cancels, and leave them as a factorial. All right, same idea here for number 5. 99 factorial over 100 factorial. Like the last problem, hopefully we recognize that 99 factorial down is going to cancel on the top and the bottom. There's no way we'd want to write all these out. So I'm going to leave this as 1 over 100. 99 factorial over 100 factorial times 99 factorial, because I know I'm going to count down to 1, is going to cancel, giving me this answer. All right, the next problem is 3 times 4 factorial. Understanding it's not 3 times 4 factorial, it's 3 times 4 factorial. So my math, wrong one, is going to be 3 times whatever 4 factorial is, and 4 factorial is 4 times 3 times 2 times 1, and multiplying this out, 3 times 3 is 9, 4 times 2 is 8, giving me an answer of 72. So whatever 4 factorial is, which we found earlier to be 24, we can multiply that by 3 and get 72. All right. When you start doing this work on your own, I'm going to be available. Let me go to our classroom page. Hopefully you get to the right one. I'm going to have times where I'm going to be at my computer or have my computer close. If you have questions, you can always email me at any time and I'll get back to you as soon as I can. Or if you come on during this time frame between 9 and 10 in the morning, 2 and 3 in the afternoon, you can contact me using Google Hangout, which is your Google chat, which they should have enabled for you, or send me an email. We're also going to have an option of they have a Google Meet, which is a option for us to click and invite each other to be able to chat and have like a video back and forth where I can show you what I'm doing on paper and you can show me what you have on your paper by holding up to your camera or whatever you need to do, and I'll be able to help you a little bit that way. All right, so one of the 2 main concepts now, we're going to talk about permutations and combinations. This reads the number of permutations n terms arranged r items at a time. So I'm going to have the number of permutations of 12 terms arranged 3 at a time. The most important concept for this is that order is going to matter. 1, 2, 3 is not the same as 3, 2, 1. They're 2 different things, 2 different orders. To calculate this, we're going to do n factorial divided by n minus r factorial and do the math. If you don't know anything else, the most important concept for permutations is that the order makes a difference. 3, 2, 1, 1, 2, 3, 2, 1, 3 are 3 different ways to write it. Order makes a difference. They're the same 3 values, but different order matters. All right, so the idea is going to be, if I gave you the letters A, B, C, and D, what I want to know is how many different ways I can put one number in the front and one number in the back. So what I'm going to do is I'm going to pick 2 of these at a time, and I'm going to put them in different orders because the order makes a difference. So what I have is AB is one way to pick them, AC, AD, then I can go BC, BD, and then lastly CD. 6 different ways to pick 2 terms. But with those, I can also say BA, which is different than AB because the order makes a difference. CA, DA, CB, DB, and DC, which is 2, 4, 6, 8, 10, 12 different ways to write 4 terms 2 at a time. AB, AC, AD. All right. Permutations, AB and BA are 2 different ways of doing it. When we get to the next section, which is combinations, those are one way because the order doesn't matter. All right, so the math behind this, if I have 4 terms and I want to arrange them 2 at a time, number of permutations, 4 terms 2 at a time, I'm going to go I'm going to go 4 factorial over 4 minus 2 factorial, which is 4 factorial over 2 factorial, which is 4 times 3 times 2 times 1 over 2 times 1, give me a total number of 12 ways of doing it. If one number is larger than the other one, that's always your n. It's the larger numbers first, but the second number can be the same if it needs to be. All right, so number of permutations of 4 terms arranged 2 at a time. 4 factorial over 4 minus 2 factorial, and you do the math. All right, so try number 8. So now I have 12 terms, and I want to pick 5 of them at a time. 12 things, and I want to put them in order 5 at a time. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1 are two different ways of doing it. All right, do the math. I'm going to write 7 factorial instead of counting down to 1 because 7's down are going to cancel for us. So now those cancel and go into my calculator because we could probably get this math to work, but we're not going to. 12 times 11 times 10 times 9 times 8 times 7. Nope, not times 7. Hit enter. And there's going to be 9,540 different ways to arrange 5 terms out of 12. Order matters. All right, so you can have the formula 12 factorial over 12 minus 5 factorial and do the math like we did on number 1. All right, that's the math behind it. We're going to have to be able to understand, and probably the biggest concept we're going to need is going to be deciding if something's a permutation where the order matters or a combination where I just want a group of things. All right, so number 9 says a child is playing with 10 trains. How many different ways can a child hook 6 trains together? Which means I want an engine, let's say up front, and then a car, to the 6th one being the caboose. That's one way of doing it. Switching cards around makes a different permutation. So order matters when you're putting something in line, when you're giving it a name, when you're putting it into specific slots. So for this, 10 trains, and I want to pick 6 at a time, it's going to be 10p6. Right? So when we have a situation where we're putting things in a line, hooking them in a certain order, it's a permutation. 10 factorial over 10 minus 6 factorial, 10 factorial over 4 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, because I'm not going to write out 4, 3, 2, 1. Then go into my calculator. 10 times 9 times 8 times 7 times 6 times 5, 4. Give me a total number of 151,200 different ways. If you have 10 trains or 10 anything, and you want to put them in order 6 at a time. It's a lot of different ways. I mean, you can sit down and write them all out or get 10 trains and put them in order, but it's a lot easier to use the formula. All right, now the idea for number 10, how many ways can we hook all 10 together? We're going to end up with (10p10), which is 10 factorial over 10 minus 10 factorial, 10 factorial over 0 factorial. First thought says, wait a minute, I have a 0 on the bottom, something's wrong, but we're going to get to what that is in a moment. But 10 factorial over 0 factorial. All right, we're going to do this one differently. We're going to let Desmos do this one for us. So going to Desmos, and pause it if you need to. We're going to go to Functions, Statistics, NPR. It gives us a parentheses. What we're going to do is we're going to put the big number, or the first number, comma the second number, and it's going to give us an answer, which means there are 3,628,800 different ways to line up 10 trains, to line up 10 people, to line up 10 of anything, if we do all 10 at a time. All right, so now looking at the math, okay? What can help us, and you'll have a calculator for some of the tests, but not all of the tests, and Desmos. Just going over here for Desmos, if I type in 10 factorial, it gives me the same answer, 3,628,800. So 10 factorial is that number, and 10 factorial over 0 factorial gives me the same number. So if that's the case, 0 factorial, if these are the same, has to equal 1. So anytime we have 0 factorial, we're always going to have the answer 1. All right, so 10p10 is really just 10 factorial over 0 factorial, which is 1, giving me that really, really big number. So permutation, it matters what order they go in. All right. Okay, next problem. There are 10 teams in the Peninsula District. How many different ways can the teams finish first, second, and third? All right, so the Peninsula District has 10 teams. You're talking all the Hampton schools, all the Newport News schools, Gloucester. 10 different teams. What we want to figure out on any sport, not taking ability into it, we really don't want to think about who's really good at a sport, who's bad at a sport. What we want to know is how many different ways can the teams finish first, second, and third if we don't even take ability into account. All right, so when we have to give someone a title, like first place, second place, third place, secretary, principal, or secretary, treasurer, vice president, president, giving people title or positions, it's a permutation. So I'm going to do permutation, 10 permutation of first, second, or third of 3 places. All right. Since we're given names, putting them in order, first, second, and third, this is a permutation. All right, doing just the math again, going to Desmos, I'm going to make it easy. I'm going to go up here and change this to a 3. There'd be 720 different ways if we had 10 teams that they could place first, second, and third. 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. Doing the math just to show you. And this one's not a bad one. 7 factorials cancel. 9 times 8 is 72, times 10 gives us our 720 different ways. Permutations, you're given names. You're lining them up. It's not a group of something, they have a particular order. That's going to be the main difference. All right, now combination. Order does not matter. I'm going to pick 5 of you to do something. Out of all the colors, we're going to pick 3 of them. It doesn't matter what order I pick those in, I'm just going to have a group of something. So the combination of n terms r at a time. It's the same formula, except we're adding an r factorial at the bottom. That r factorial at the bottom is going to take out all the ones that use the same values in just a different order. Combination order does not matter. Permutation, it does. All right, so this time, if I have A, B, C, D, and I want groups of 2, one group of 2 is going to be AB. Then we're going to go with AC, AD, BC, BD, and CD. If all I do is change the order, it's not a combination anymore, because AB and BA are exactly the same. They're not different when you're talking about a combination. So I'm not going to go through and write them all again because AB and BA are the same ones. That only counts as 1. AC and CA, because order does not matter, only counts as 1. So there's 6 ways of doing this. All right, now by hand, just to do the first one, let's see, and then we'll do the second one on the calculator, or Desmos. We're going to go 10C3, the combination of 10 terms, 3 at a time, which is going to be 10 factorial over 10 minus 3 factorial, 3 factorial. 10 factorial over 7 factorial, 3 factorial. So I'm going to write this out as 10 times 9 times 8 times 7 factorial, because it's going to cancel out with the one on the bottom. Then 7 factorial times 3 times 2 times 1. All right, if I did the math, my 7's cancel. I get 720, 10 times 9 times 8 over 3 times 2 times 1, which is 6. If we can't figure that out without a calculator, we can back up a step You realize, wait a minute, 2 goes into 8 4 times, 3 goes into 9 3 times, 3 times 4 is 12, times 10 gives me 120 different ways. All right, so this one is 10 things in groups of 3, where that group, it doesn't matter what order you picked them in, as long as you have all of them. All right, again, as we go through these, pause when you need to. 8C7. All right, let's go to the calculator, or Desmos this time. All right, so we're going to go functions, combinations, 8, 7, parentheses, which tells us there's a total of 8 ways to do it. The math, 8 times 7 factorial. I'm going to back up a second. 8 factorial over 8 minus 7 factorial, 7 factorial, which is 8 times, I'm going to realize 7 is going to cancel down, 1 factorial, 7 factorial. I'm not going to count down because that's a good thing, which gives me 8 over 1, which is 8 ways, just like the computer said. You'll probably have a, when we take our test, whenever that happens to be, you'll have a portion with and without a calculator, or with and without Desmos. The ones without Desmos, you won't have big numbers. The ones with will probably be bigger where you'd want to use it. All right, so a combination, if you don't remember anything else, order does not matter. AB and BA are exactly the same. Going back to here, permutations, AB and BA are different because the order is different. Permutations, it matters what order they're in. Combinations, it does not. All right, so how many different ways can you choose 4 letters of the alphabet? All right, so if I'm only choosing 4 letters of the alphabet, I'm not asking you to put them in a certain order, make certain words. I just need 4 letters. It's a group of 4. Since it's a group of 4 where order doesn't matter, it's a combination. Probably the most we have to think about this one after we decide it's a combination is how many letters are in the alphabet. And hopefully without thinking, we all know 26. So this is going to be a combination of 26 terms, 4 at a time. Looks like it may be a difficult problem to do by hand. 26 factorial over 26 minus 4 factorial 4 factorial. 26 times 26 factorial over 22 factorial 4 factorial. Yeah, we're just going to stop there because that's going to get a little ugly. So it's 26 and 4. So I'm going to go back to here and erase a couple numbers. And there's going to be 14,950 different ways to pick 4 letters of the alphabet. Not putting them together making words, just picking 4 letters. I've said it a bunch already. That's the difference between combination and permutations. The formulas are different, but you can memorize that. Combination is you want a group of something where the order doesn't matter. A permutation, you want to put them in a certain order. You put them in a certain line, put them in a certain hole, give them a certain name, something like that. All right. So what I'm going to do next is I'm going to pick 12 people in this class to pass. Let's pretend that we have 22 people in the class. All right. So out of 22, only 12 get to pass. Think, does it make a difference if what order I pick those 12 people in, if all I'm going to give, if it's a pass-fail course? Either you pass or you fail. 12 will pass, 10 won't pass. How many different groups of people can I choose? Hopefully you realize that's a combination because I'm not saying one person gets an A, one person gets a B, one person gets a C. It's 12 people getting a passing grade, the rest not getting a passing grade. So this one is going to be the combination of 22 terms, 12 at a time, because 12 people get to pass out of that 22. Go into Desmos, 22, 12. So there would be 6,400 646,646 different ways out of the 22 people in the class that I could pick 12 of you to pass. Doesn't matter who gets the highest grade and who gets the lowest grade of those passing grades. It's just you get to pass total. Order is important. All right. 17. There are 12 girls on a basketball team. How many different starting lineups could be made? When we take our test or quiz, I'm going to make sure that the word problems I use will help you, and you should understand and know the situation. Not everybody knows sports, not everybody knows different concepts, but understand that on a basketball team, 5 play at a time. All right, so what I'm looking for is how many different ways, if I have 12 players on the team, that I can make a starting lineup of 5 players. Again, this one takes out, doesn't say I want to pick the best starting lineup, I want to pick the worst starting lineup, I want 1 tall, 1 short, and 2 and 3 in the middle. It's just picking 5 people. Since order doesn't matter if I just want a group of 5 people, and that's the idea, is how many different starting lineups means I want a group of 5 people. It's going to be the combination of 12 girls, 5 at a time. Order is not important since it's a combination, and also because it's a starting lineup, it's not the best starting lineup, it's not a good one, the worst one, whatever it is, it's just a starting lineup, how many different ways. All right, we'll do this one by hand. 12 factorial over 12 minus 5 factorial, 5 factorial, 12 times 12 factorial over 7 factorial, 5 factorial, 12 times 11 times 10 times 9 times 8 times 7 factorial, 7 factorial times 5 times 4 times 3 times 2 times 1. All right, so if we had to do this, 7 factorials cancel out. Now I'm going to piece and part this. 5 times 2 is 10, so I can cancel those 2 out with the 1 on top. 4 times 3 is 12, and I can cancel it out with the 12 on top. So now 11 times 9 times 8, yeah, probably still too much for us to do, but that's fine. 11 times 9 times 8. Hard to see, but it gives us 792 different ways it can be done. Starting lineup of any sporting team. You can put anybody in any position you want. They may not be good at it, but it's still an option. All right, you can put your shortest person at center. Not smart, but it would work. All right, so for a basketball team starting lineup, order doesn't matter. All right, now the last idea. Given a situation, I'm not going to ask you what the answers are. We just need to be able to decide if order matters, it's a permutation. If order does not matter, it's a combination. All right, so number 18. How many different batting orders can be written for a 15-girl softball team? All right, so we're not asking for a starting lineup, like who can play what positions. What we're asking for is a batting order. In baseball and softball, order makes a difference. Whoever bats first can only bat first in that order, then second, third, all the way through. You can't change what position you are in the batting order. Once you're put into it, you're stuck. So what this is, this one's going to be a combination because order makes a difference. Some of these, I'll make sure, again, that when we have a test or a quiz, it'll be a little more obvious if you don't know the situation. All right? Different hands of poker can be dealt in the game of poker. You can say it's different hands of go fish, whatever the game is. All right? So when you're dealing cards for a game of poker, go fish, whatever you want to call it, you're going to have a group of cards. Once you get those cards, you can change those cards in any order you want in your hand. Since you can change the order isn't going to matter, and this is going to be a permutation. Order is not important because you can put the order however you want. And the last one's a pizza. Our pizza restaurant has 15 toppings. How many different pizzas can be made having 3 toppings? All right, so they have all the toppings: pepperoni, sausage, green peppers, black olives, all that good stuff. We want a pizza with 3 toppings. So we want a pepperoni, sausage, and green peppers. All right, so if we want a pepperoni, sausage, and green peppers, if I order a sausage, green peppers, and pepperoni, will I get the same pizza? If I order green peppers, pepperoni, sausage, is it the same pizza, or is it going to be a completely different pizza because we asked for it in a different order? Hopefully you realize in a pizza, it doesn't matter which one you put on first, which one you put on second, which one you put on third. It's still a pizza with those toppings. This last one, again, it's a combination, because when you have a pizza, when you make a sandwich, it doesn't matter truly what order you put them in. You may have a preference, but it doesn't make the difference of what that sandwich is. All right, and this is going to be the biggest idea that we need to know, because when it comes to SOL time, you're going to be given a situation like this, and a calculator is going to be in your hand. Once you realize it's a combination or permutation, we're going to be able to plug it in how we want to. All right, now the last idea. All right, since we're not in the class, I'll make up some numbers. All right, let's say we have 12 boys and 14 girls. So we have a class that are 12 boys and 14 girls. I'm going to choose 3 boys and 3 girls to automatically get 100 on the next test. How many different groups of 6 can be chosen? All right, so there's 12 boys. I'm going to pick 3 and give them 100. 14 girls, I'm going to pick 3 and give them 100. So I want to know how many different ways I can do this, because it's going to be a group of 6 total. Is this going to be a permutation where the order matters, or is this a combination where I just want a group of 3? Hopefully you realize it's a combination, because I'm not given different grades. I'm not saying one person gets a 99, one gets a 98, one gets a 97. Everybody's getting the same grade. So if I pick Sarah, John, and Betty, or I pick Betty, John, and Sarah, it's still the same group of 3 people. All right, but we have 2 different situations. I have boys and girls. So when we have a permutation / combination, whichever one it is, it has 2 different situations that have nothing to do with each other. We're going to have to do this one in 2 parts. So what we're going to do, the first one, is it going to be the combination of 12 boys 3 at a time, and the combination of 14 girls 3 at a time. All right, we're going to get 2 separate answers first. So let's go combination (12, 3). There's 220 ways to pick my boys. 14, 3. There's 364 ways to pick my girls. All right, so if the problem was only picking 3 of the 12 to get 100 for the boys and 3 out of 14 to get 100 for the girls, it would be those 2 numbers: 220 boys, 364 for my girls. Different ways to do it. But when you have 2 combinations that you want to put together, you're just going to end up multiplying those 2 together. 220 times 364. And total, there's going to be 7,280 different ways to pick 3 boys to pass out of 12 and 3 girls to pass out of 14. So whenever you have a combination or permutation that you need to put together into one situation that are completely different situations, multiply those 2 answers together. All right, that's the first lesson we have. We have 2 more lessons in this unit. We're going to talk about mean, median, mode next class. Or not next class, I'll change that up a little bit since we're not meeting. The next lesson, which I will post on Thursday morning. And then the next one is going to be talking about normal distribution, which will be posted on Monday morning. If you have any questions after you look over this from 9 to 10, I'll be available tomorrow. And then from the other time I said was from 2 to 3, I'll be available. You can go on Google and chat with me. You can send me an email. You can go on Google and do a meet, which will allow us to have a FaceTime type conversation with each other. And we can look at your work. You can look at what my work is, and it might be a little bit easier to work through. All right, so whatever works for you. But by then, by that Thursday, really, or sometimes soon. This is the assignment that's in your book. If you have any questions, please send me an email. Chat with me during those times. You can send the chat beforehand, and I'll just respond when I open it up at that time. All right. Make sure you're doing this. The more we can do while you guys are out of school, the easier it's going to be whenever we get back. All right. If you talk to your friends, make sure they're doing what they're supposed to do. But let's get some of this done, so our life is so much easier when we come back, and we can truly get some stuff done. All right. If you need anything, let me know.